I'm about to bust. Oh, I'm sorry. I thought this was the bathroom. Oh, good Lord.
So for question 1, there are 2 positive point charges. We can name it charge A and charge B. And this one is charge B. For question A1, calculate electric field strength at X. So at X, the electric field line induced by A is in this direction, and the electric field line induced by B in the other direction. The electric field strength at X is equal to the sum of electric field strength at A and the electric field strength at B by B. So to calculate electric field strength, we use this formula. We calculate electric field strength by A and by B. So for A is K times with the charge of A, divide by the square of distance between charge A and X, equal to K is 9 times 10 to the power of 9, and X is the distance midway between 2 charges. So it's in the middle, A and B, which is 0.2 square. And the charge of A is 10 to the power of minus 9. Then we can get the answer 2700. With the unit, Newton per Coulomb. And we have electric field induced by B. B has the same charge as A, and the distance between B and X is also the same. So electric field induced by B is the same as electric field induced by A. To get the electric field strength at X, because electric field is a vector quantity, so we need to take into account that electric field at B is opposite to electric field induced by A. So E at X, we have opposite direction. E at X is basically E induced by A minus E induced by B, which is 2700 minus 2700 equals 0 Newton per Coulomb. For A2 at Y, we have electric field induced by A in this direction, and electric field induced by B is also in the same direction. So again, we will calculate the electric field induced by A on the point Y. K is 9 times 10 to the power of 9. Charge A is 3 times 10 to the power of minus 9. Distance between point A, distance between charge A and the point Y is 0.2 plus 0.1 square equals to 300 Newton per Coulomb. Electric field induced by B on Y, K is 9 times 10 to the power of 9. Charge of B is 3 times 10 to the power of minus 9, and distance between charge B and Y is 0.1 square. we get 2,700 Newton per Coulomb. E at Y is electric field induced by A at the point Y plus electric field induced by B at point Y, and they have the same direction. So E at Y is EA plus EB equal 2,700 plus 300 equal 3,000 Newton per Coulomb. Direction to the right. B is of the term potential. Electrostatic potential at a point is the work done per unit charge in moving that charge from infinity to that point. That's for B. Proceed like electrostatic potential difference between X and Y. So to calculate the potential difference between X and Y, we first find electrostatic potential at point X. We have Vx equals to the work done in bringing charge A to point X plus with the work done in bringing charge B to point X. Formula of work done is K times with charge A divided by the distance between A and X. And for potential of B is K times with charge B divided by the distance between B and X. K is 9 times 10 to the power of 9 times with charge A 3 times 10 to the power of 9 minus 9. Distance between A and X is 0.1. Same thing for potential of B. The answer is 540 volt. Then we find the electrostatic potential at point Y. Same thing. Work done to bring charges to point Y is equal to the work done to bring charge A, Y, and work done to bring charge B to Y. The same formula. Distance between charge A and Y is 0.3. Between charge B and Y is 0.1. And the answer is 360 volt. Electrostatic potential difference between X and Y, we have delta Y is equal to Vx minus Vy, which is 540 minus 360 equal 180 volt. That's for question 1. For question 3, calculate the magnitude point P. The electric field at point P caused by the charge Q1 is in this direction, and the electric field caused by Q2 is in this direction. So first we find the electric field at point P caused by charge Q1. K is 9 times 10 to the power of 9. Charge of Q1 is 2.5 times 10 to the power of minus 6 Distance between Q1 and P is 0.05. Answer is 9 times 10 to the power of 6 Newton per Coulomb. Same for electric fields caused by charge Q2 at P. K times with charge Q2 divided by the square of distance between charge Q2 and P, 0.12 square. And the answer is 1.56 times 10 to the power of 6 Newton per Coulomb. Then we draw a vector diagram, Q2 and Q1. And we know that this angle is 90 degrees. Using the Pythagoras, we can calculate the magnitude of electric field at P equal to the square root of Q1 square plus with Q2 square. Electric field by charge 1 is 9 times 10 to the power of 6, and charge 2 is 1.56 times 10 to the power of 6, which is 9.1 times 10 to the power of 6 Newton per Coulomb. As for question 3. For question 9, calculate the charge on H. We use the electrostatic force formula. The force is already given, which is 3 times 10 to the power of minus 5. K is 9 times 10 to the power of 9. These two charges have equal charge. Q1 equal Q2. So we can just shorten it into Q1 square. Distance between two charges is 40 millimeter, which is 4 times 10 to the power of minus 3 meter. From there, we can get Q1 square as distance square times with 3 times 10 to the power of minus 5 divided by 9 times 10 to the power of 9. So 5.33 times 10 to the power of minus 20. Then Q1 will be the square of 5.33 times 10 to the power of minus 20 equal 2.3 times 10 to the power of minus 9, which is also equal to 2. For B, calculate electrostatic potential at P. So V at P is equal to the work done in bringing charge E plus with the work done in bringing charge Y to P. Using the potential formula, K times with charge X divided by distance between X and P plus with K times with charge Y divided by distance between Y and P equal to 9 times 10 to the power of 9. Charge as at X is 2.3 times with 10 to the power of minus 9. Distance between them is 10 millimeter, which is 10 times 10 to the power of minus 3 meter. Same thing for y. Since y is negatively charged, so the charge of y, there needs to be a negative sign, because the potential of a negatively charged, the work done in bringing a negatively charged particle will be a negative value. The distance between y and p is 50 to the power of minus 3 meter. Then we'll get 2,700 minus 414 equal 1656 volts. X is positive. For B, for C, draw a sketch on how charges are. So here X and sphere Y charges are distributed on the surface, near the surface of the sphere. Y is a positive charged sphere, so it will have positive charge spread around the surface, while y is a negative charge here, so it will have negative charge around a surface. E, sphere y has the mass of and hangs at an angle. Calculate the tension T. So this sphere will be affected by this horizontal force together with weight. Here, y is hanging, y hangs at an angle, so it is, y is stationary, meaning the forces are in equally, so we can break down the tension T into horizontal and vertical components. This is T, this is weight, which is equal to mg. Mass of the sphere is 2.5 times 10 to the power of minus 5. G is 9.8. This is equal to 2.45 times 10 to the power of minus 4 Newton. And this horizontal force is already given as 3 times 10 to the power of minus 5. So again, using Pythagoras theorem, is equal to the square root with horizontal force equals to 2.45 times 10 to the power of minus 4 square plus 3 times 10 to the power of minus 5 square. And this is equal to 2.5 times with 10 to the power of minus 4 Newton. The size of angle alpha, so we can use calculate size of can use tangent of alpha is equal to horizontal force divided by weight, which is 3 times 10 to the power of minus 4 divided by 2.45 times 10 to the power of minus 4. And we'll get alpha equal 6.8. For question 11, A is to draw electric field lines between charge Q1 and Q2 because these two charges are both negative charges, so they will repel and their electric field lines will show the repulsion. Something like that. For B, calculate the potential at point X. Midway between the charges, electrostatic potential at X. So we have Vx equals to Q1 plus with using the formula KQ over R, we have K as 10 to the power of 9. Q1 is 4 times 10 to the power of minus 9. Distance between Q1 and X is 0.3. For V of Q2 is the same, negative charge. And the answer is minus 2.4 times 10 to the power of 5. Third point charge Q is placed near the two charges. I find the force between Q1 and Q3. F13 equals to K Q1 Q3 over distance between 1 and 3 squared. So first we need to find a distance between Q1 and Q3, which is this. Using Pythagoras theorem, distance between Q1 and Q3 equals to the square root of 0.3 square plus 0.4 square equal 0.5 meter. So here we continue. K is 9 times 10 to the power of 9. Charge Q1 is 4 times 10 to the power of minus 9. Charge Q3 is 8 times 10 to the power of minus 9. Distance between them is 0.5 square. The charge is to the power of minus 6, which is equal to 1.2 Newton. To calculate the magnitude, force of Q1 on Q3 will be this way, and force of Q2 on Q3 will be in the other direction. 2, 2, 3. We have F of 1, 3 equals to F of 1, 2, because charges of charge 1 and charge 2 has the same magnitude, and the distance of 1 and 3 compared to 2 and 3 are also the same. So the resultant force will be the same, which is 1.2 Newton. We use vector diagram F13 and F23. Then we will break down these vectors into vertical and horizontal components. So let's call the angle here alpha. This vertical component will be F23 sine alpha and cosine. And this horizontal component will be F23 sine theta. For F13, we do the same thing, break it down into horizontal and vertical components. This will be F13 sine theta, and this will be F13 cosine theta. The resultant force on charge Q3 will be this force, in this direction. From the diagram, it can be seen that F23 sine theta sine alpha and F13 sine alpha cancel each other out. Therefore, F net will equal to F13 cosine alpha plus F23 cosine alpha. This will be F13 cosine alpha. 1,3 equal F2. And this alpha, this angle, to find the angle, we use the help of the original diagram, 0.5, 0.4, 0.3, alpha is here. So sine alpha 0.3 over 0.5. And let's just use cosine. Cosine alpha is equal to 0.4 over 0.5. Substitute that into the F net. So 2 F13 cosine alpha equals 2 times 1.2, 0.4 over 0.5, which is 1.92 Newton. Direction is vertically upwards. And that's it.